So this is the last afternoon of the conference. I hope you're enjoying as much as I am, and we the team are. Now Guillem is going to talk us again about blockchain. He's an aerospace engineer who became a data scientist, and I don't know you, but I've been hearing about blockchain lately, so I think it's going to be like the next hype, so I'm really excited. So Guillem, this is all yours. Give him a round of applause.
Thanks for the introduction. I think that there's only one thing that has received more hype lately than neural networks, and that is blockchain. I mean, the hype that this has in the corporate and financial world dwarfs the one of machine learning. And it's sad because what happens is that it's something that's quite easy to understand, or at least the ups and downs that this technology has. It's quite easy to understand. So I'm here to fix that. This conference, this talk will be successful if after that you more or less have an intuition of what are the good things and the bad things that blockchain, distributed ledgers, which is the kind of general technology that how you name in a more general way this technology, and smart contracts work. Mandatory slide about me. You've probably seen that 3 times, so I'm sorry. Again, my Twitter, and I don't tweet so much. We're hiring. No one has come to me yet to say what kind of profile you want, at least. So you're not that interested. I don't know. We're a fine company, I think. And here's all the talk materials and all the information you need. This blockchain and distributed ledgers, it has a nice kind of white paper. It's not very long, but I think that if you like this talk, you should read it. It's more or less the content of this talk, but this is a good way to remind what I've just said. So, blockchain. Who here has ever heard of Bitcoin? Good. Who here has ever heard of blockchain? Good. Who here has ever heard of distributed ledgers? All of you should have raised the hand because a distributed blockchain is a distributed ledger, okay? But first of all, what is a ledger? This is a ledger, okay? It is a table. It can be in paper. It can be a database. It can be in whatever format. A ledger is a series of ordered records, no matter what they contain. The only thing is that they are ordered, and they kind of keep consensus between several peers on what is the status of all the collective. In this case, this is a census. It keeps a record of all the people who is registered in the census, so that's the people that has the right to vote. But you may think that this is quite old, so ledgers we've been using ledgers for quite a long time. Well, it seems that we've been using ledgers for several thousand years. So that's definitely not a new technology. Ledgers are the bread and butter of accounting, registration, auditing. Ledgers are the way in which mankind makes business. Everything that is not in a ledger just doesn't exist because we cannot find an agreement on that. So how ledgers have worked for 7,000 years? And I'm not exaggerating. It's about 7,000 years. We've been doing business the same way. It's very simple. You have an authority that it is either imposed to you by a further authority, a government, a supranational institution, and they say, okay, this institution will hold the data of the ledger. It can be, again, someone that has some power, or the several members of the community or group or whatever agree who has to hold the data. The important thing of the ledgers is that he who holds the data also has the liability and responsibility to keep that data safe and not tampering with it, not using it in his own interest. And that is important. And usually, for this liability, he charges some money. It's a service. If I keep a ledger of, the transactions that several banks do between them, I can charge them for that, storing that information, because if my system just breaks down or I accidentally delete some of those information, those banks can sue me, and then I have a problem. So it's a kind of mutual economical agreement. But the important thing is that no matter how money you charge for keeping that ledger, that central authority gets how much money it gets to keep that ledger, the whole thing is based on trust. Even in Mesopotamia, the guy that kept that thing was trusted by the people who asked to put that annotation on that piece of clay. Okay? That is important. And what happened when one of those ledgers had some issue? It burned, or the institution collapsed. Very easy. All the members of the group that used that ledger went to a different institution that kept the information on a similar way. Now we use databases, but it's very similar. Okay, but what happened in 2008? A global financial meltdown. I think that you all remember that. And what does a global financial meltdown mean? It is a crisis on trust. Banks started selling each other toxic assets. People lost their money. There was a huge crisis on trust. But this doesn't mean that the important thing, the huge difference between the last global financial crisis and all the financial crises that ever happened before was that for the first time in history, they could choose. And this is something completely new, and it's what blockchain and Bitcoin brought to the game. For the first time, they didn't need a central authority to hold the data. For the first time, and this is important, blockchain was the first case in which you could hold a market in a completely distributed manner, and you should not trust a central authority. It was for the first time that the data, that ledger, was not owned by anyone. And this anyone couldn't apply the authority on that data. The data was everyone's. Okay? What is a smart contract? I don't know why every time that someone talks about smart contract, they put pictures like that. The problem I have is that every time that I see two persons holding hands, I think about this. But anyways, what is a smart contract? And this is curious because people think nowadays that smart contracts and distributed ledgers are a very related thing. And they're not. They're completely separate concepts. And that's curious how the hype, how building a discourse changed people's perceptions. It's not that. If you go to the Wikipedia and you pick the definition of smart contract, it just says it is a computer program that allows or facilitates the negotiation between two parts. Where's Bitcoin there? That definition doesn't need a distributed ledger at all. Doesn't say anything on how you must store the data of that agreement. So why people think that a distributed contract has to go with blockchain? I mean, their answer for that is no. I mean, there's a lot of people that it has built this discourse, but that's not true. Again, if you have a distributed contract, you need to store that in a database, okay? And we've seen that it is good to have this database distributed, okay? But what people don't tell you, and this is something that's very important when you design this kind of smart contracts on distributed ledger, is the cost you pay for keeping that data distributed, okay? So you have two models. It's important to keep that in mind. You have two models. The model that has been working for 7,000 years, which is keeping that information centralized, and one owner keeps that data safe, or going to a distributed ledger, okay? And we can understand distributed ledgers and the price we have to pay for going to a decentralized model with very easy theory on computer science. And this is the basic theory, and it is quite basic. You will see that. Allows you to understand the ups and downs of going from a centralized model to a distributed model. And I can tell you, you will see that in a moment, it has a huge payoff. It's not free. And why is that? From what the costs come? Who knows about the cap theorem? I think that the most people that just raised the hand are also computer scientists, probably, or have worked with distributed systems. That is a theorem. It's not the cap theory. It's the cap theorem. It means that it has been proven. What that theorem says is that if you want to store data in parallel in a distributed system, you have three possible promises. One is that the data will be in a consistent way. It means that the last status will be available. That means consistency, is that all the nodes are able to see the same data. It will mean availability means that the data will be available immediately. So see, I carry a distributed database, and availability, it means that it will never answer an error or I don't know. Or wait. No, it will mean that I can access the data immediately. And finally, partition tolerance. That means it has a more complicated definition, a more complex definition, but it basically means parallel. So if you want to be distributed, you have this. There's no other way. So you have to choose between one of those two. And which one you need? Availability or consistency? You're building a ledger. It's this. You need this too. And this is the one hanging. What does availability mean? Availability means latency. Okay? If you put data in parallel and you want to build a distributed ledger to hold contracts, you will have latency. You will have to wait for that contract to be signed somehow. Okay? But how much latency? And that is important. You know now that you have some latency, but how much? Okay, I've said first concept, cap theorem. The second concept, who knows about the Byzantine agreement problem? 1, 2, 3, 4. There's one problem. It was stated by Leslie Lamport like 20 years ago. Since it's a Python conference, instead of calling it the Byzantine generals problem, I will call it the French castle problem. Okay? Okay, imagine that you have a series of generals, and they're trying to invade a Byzantine city. Sorry, you're part of the Ottoman. You want to invade an Ottoman city, and you're a set of Byzantine generals. And they're camped around the city. And they know that they can win that battle if they agree on how to attack or retreat. Okay? The only requirement for them to be victorious is that whatever the strategy is, either attack or to retreat, all of them must apply the same exact theory. If only one of them applies a different strategy, they lose. Okay? So if you think about that, it's okay, I have many generals, and they must do the same. And it seems easy. Okay, in the most general form, it is proven that this problem has no solution. Because at first you can think, okay, I have one general traitor. One general is a traitor. Okay, just cheat him. I will attack. I just tell him that we will retreat. He will apply the inverse strategy, and I win. But what happens if one of them is deaf? One of them is sick in the tent. 2 of them are traitors. 3 of them are stupid. You lose. But that's important. I've said kind of 2 possible cases. You have one general who is a traitor, or you have a huge problem for consistency. Again, remember the cap theorem. Consistency is what you want. Okay? And I've said, okay, now I have a problem of latency, of availability. How much latency do I have? And this is the important concept that the Byzantine agreement provides. The harder the Byzantine agreement is, the more latency I will have. If I'm trying to solve an easy Byzantine agreement problem, which is that I have a faulty network, then I will be able to find a consensus very rapidly. But if all the people who's using the network is trying to cheat me, then finding consensus on which data I have to store, it will be very hard. Okay? So the harder the consensus, the more latency I have, because I need more time to reach a consensus between all the pairs. So I think that we have easy concepts now. Consensus, and I want to store information in parallel and in a consistent way. Blockchain is an example of that. Blockchain has a Byzantine agreement problem, which is double spending. Okay? What is double spending? Very easy. I hold my blockchain, and I try to cheat someone, two people, to spend the same, exact same blockchain in two different transactions. And I hope that these two people will never look at the same time if I already transferred those blockchains. Sorry, those bitcoins. Okay? So with actual cash, the only way I have to do that is to falsify the bill. With a bank, that's impossible, basically, because it's a centralized ledger. A bank has a centralized ledger and knows exactly which currency I spent. What it happens is that solving this problem, the one of double spending, is particularly hard. It's one of the hardest Byzantine agreement problems that there are. And the curious thing is that that thing was not solved until 2008. When blockchain was designed, the blockchain protocol was designed, and Bitcoin was released. That was a revolution. For the first time, we had a protocol and a system that allowed to make useful by solving a particularly hard Byzantine agreement problem. And it's solved this way. Imagine that I have Alice and Bob. And Alice doesn't trust in Bob. Sorry, Alice owes money to Bob. But Bob doesn't trust Alice at all. Says she will try to cheat. She will try to pretend that she's sending the money, but she will try not to do it, actually. So in the blockchain protocol, what they do is Alice will not actually do the transaction anywhere. He will pick the transaction with that information, like transfer that much Bitcoin to Bob. And instead of sending it to Bob, he will send it to a series of miners. And this transaction will be ledgered, will be ordered in a block. Okay? And those miners, one of them, by mere luck, that's the point of the algorithm, just one of them will make something called a proof of work, which is a very hard computation. And from the millions of, now I think there are probably millions of miners, one of them will solve this problem, and it will say to the rest of the network, these transactions that were in my block, the one I was mining, these transactions are now part of the ledger. Whatever I had, whatever transactions I received, now they're the information that everyone must trust. Again, Alice cannot manipulate those miners. She can only send the transaction. So the only thing that Bob has to do is to wait from some miner to say which transactions are the good ones. And as soon as they get added to the blockchain, Bob can see that Alice has made the transfers. And that's it. Doesn't that sound complex? For transferring money? I mean, how do you transfer money? You go to your bank, you tell your bank, transfer that money to this account, and it's done. Okay, this is because the fact of having people trying to cheat this all the time is a requirement for such a complicated agreement. Okay? So what are the costs of a particularly hard agreement protocol or consensus protocol? Okay, Each block is only 1 megabyte, which is very small. 1 megabyte. Okay? One block is mined every 10 minutes. So you have a database that has a bandwidth of 1 megabyte for every 10 minutes. Does that sound a lot? That doesn't sound a lot. It means that the whole Bitcoin and blockchain is a database that allows 4 transactions per second. Does that sound a lot? No. By the way, the blockchain is already finding the maximum. So they're just reaching the peak bandwidth. Look at that. Look at the bank. Alice wants to transfer money, Bob. Alice trusts in her bank, that trusts Bob Bank, that trusts Bob. Transfer done. But what is the price we pay here? Trust. And that is the next idea I want to put here in your minds. Not trusting in the systems is what makes things complicated. So every system that uses ledgers or tries to store information, it gets much simplified by trusting in the people that has to hold the data. So we go back to smart contracts. Smart contracts, again, they're just a way of finding agreement between 2 parts. What happens if one part doesn't trust the other one? It has to pay a price. That's it. There's no other way. But if there's some common trust between those 2 parts, they can store information in a different way, and we can make those transactions more efficient. And what happens is that there are many platforms for smart contracts right now. Maybe some of them ring the bell to you. One's called Ethereum, which is a kind of derivative of blockchain. You have Hyperledger, and then you have other protocols that are also used for financial transactions, like Ripple. But if you look at the platforms that are general platforms for smart contracts, they all look the same. You go to Hyperledger, you read the white papers. You go to Ethereum, you read the white papers. And what is a smart contract really in those platforms? A smart contract is just a series of attributes. A is equal to 1, B is equal to 2, C is equal to a list of strings, and then methods that change the value of those attributes. This is a class. In smart contract platforms, a smart contract is a class. You have attributes, and you have methods that change those attributes. That's it. It's as simple as it sounds. Where's all the complication? In storing that in a way that no trust is required. But in a class, you trust in the Python interpreter, so you just run Python. It's okay. And what did I do? Since the whole smart contract ecosystem is getting very, very complicated, just because of the infrastructure, of the possibility of not needing trust, I just did the complete opposite. I implemented one smart contract platform that is PyLedger that just stores information in a database. That's it. You can use it to play with smart contracts, to see if they're powerful, if they work for you, so you can experiment. And again, what is a smart contract? A smart contract is a class. So demo time. Oh. Yeah. Okay, I have, in this virtual environment, I have PyLedger installed. And I have a server, which is a Python file, that serves a very simple smart contract, which is a kind of stupid digital currency. And this is the smart contract. So it's all that it is. It is a class. It's digital currency that inherits from simple contract. Oh, by the way, does everyone see that? Look at this. What's this? Type annotations. I found a use case for type annotations. But see, I mean, that's a class. You have accounts, which is a class attribute, because basically smart contracts, technically speaking, smart contracts can be singletons. So you have add account, increment, transfer, balance, things that look like a currency system. And then I just run it, run digital currency. That's it. It's a class, you run a class. Okay? This is how hard it is to make a smart contract run. So I will run it. Oh, event loop. Yes, it has a sync IO in. And I run a shell, and I will connect two clients to this contract. Okay, and very briefly, I just connected it. These logs that I opened WebSocket connections is because the client and the server connect via WebSockets, and I only think they say, I don't know, contracts. So digital currency. What is the IPI? Oh, I have add account, balance, transfer, increment. Oh, well. And what is my balance? 0. Oh, by the way, this is server-based, so I can do exactly the same thing. Okay, sorry. Digital currency, balance, key, my account. Oh, account not found. It's because, oh yeah, that's because I've forgot to sync it with the database, but it's okay. The thing here is that it's the demo gods never allow you to make a successful demo, so it's okay. Eh? Oh, yeah. Oops. It doesn't have red line support. Well, the balance is 0. I can broadcast thing to the other shell. Hello. So it is a true smart contract platforms. The only thing is that you don't pay the price of having that in a huge infrastructure. Of course, that's not for everyone. But the problem I had when I tried to explain smart contracts to anyone is that, okay, how do I play with smart contracts? And the answer is that people just can't. So now with this, you can at least play with them, which is a nice thing. Oh, by the way, it's still rough around the edges. I've just changed implementation. I moved from Tornado to Autobahn because I wanted to have wet sockets to have nice things like broadcasting. So it's not perfect. But I think that's good enough, so you can play that. You can play with that. So that's all I have. Thank you very much.
Guillem, it was really interesting. If you have any questions, so I think we would be happy to listen.
Hello, thanks for the talk. Why not testing the smart contrast in a testnet? In a testnet. You know, Bitcoin, Ethereum, everyone has a testnet. and if it is difficult to get some coins for the testnet, you can forge your own Genesis block and start your own separate private testnet.
Yeah, but that is the cost. I thought about that, building a testnet, and what it happened is that how can you build a how you let a functional consultant in a consulting company to build a testnet, hold it in the systems and all that thing. And I faced the same difficulty, and I realized that, and I just tested it. It was like a crazy guess. Can I develop something in 4 days, which is the same time it takes me to understand how to build and run a testnet? Can I build a platform for smart contracts on the same time? And the answer was yes. It's just trial and error, and just this was faster.
Well, thanks for the talk. It was amazing. Have you ever tried the Solidity online idle? You can put the smart contract, and it has like a layer that you can check it, you can test it, and it's not Python, it's based on Java, but it's amazing.
No, Ethereum, what I mean is that Ethereum is great. This is not a criticism on current smart contract platforms. But the thing is that I wanted something that I can have up and running, prototyping in my laptop if I'm not connected, and I want to go with my laptop and allow someone to test it. And I want something easier, much easier. I mean, if someone tells me, Ethereum is easy, I will say it's not easy enough for me. That is my general, it's not a criticism. Ethereum is a wonderful piece of project. It solves many things. It is an amazing technology, but I want something simpler. That is my contribution.
Okay, and another question is, have you ever tried the Python library for Web3? It's the
Python library for?
Web3 is the API for working with Ethereum.
No. I opened it and I looked at it. I didn't plan to use it because I already have a knowledge about Geth and all the command lines for Ethereum. And the thing is that once I saw that, I just jumped in trying to develop something.
Questions?
You mentioned that the bandwidth of Bitcoin is just 1 megabyte every 10 minutes on average, but there are some projects to alleviate that. For example, the Lightning Network, in which with micropayment channels you don't need, you can have thousands of transactions, virtual transactions per real transaction. So, do you think we need to worry about the bandwidth problem? Yes,
everyone's worrying about the bandwidth problem. Because the problem is that again, it's about consensus. You get to a sub-payment platform, then which one? Then you have 30 different platforms that rely on blockchain for sub-transactions. The Genesis blocks for Ethereum private networks are also stored in the blockchain. The problem is, again, agreement. The nice thing about the blockchain is that for the first time, people agreed on something that was distributed. And it has nothing to do about technology. This is social. And what's happening now is that people is designing protocols. Those protocols that may be successful are the ones that are not based on the blockchain, like Ripple. Ripple is a great protocol, and they probably will make a lot of money. Because they understood that maybe they have to use a different kind of agreement protocol. What I mean is that this is not settled. There are a lot of things. And who knows where the market will go. But smart contracts will be there, and I just needed something to test them.
Any?
Hi, Guillem. Thank you for the talk. I was just wondering, do you see, so you mentioned that in your case you built PyLedger to have something simpler, and you assume trust in many occasions. Do you see applications for this type of smart contract way?
The simple smart contracts that are not distributed, what I call the ledgers.
Yeah.
Yes, I do. Probably they will not be based on PyLedger because it's a toy. But I think that they have, this has nothing to do with programming, okay? Banks base their business on trust. I'm sure that they will base, if some bank kind of creates a platform for smart contracts, they will try that you trust them. So at the end, the model they will try to impose is one in which they store all the data. So if some authority asks you to use a smart contract, it will be more similar to this than to the blockchain.
Thank you.
Hello. I was wondering also, don't you have to trust then in the miners in the blockchain model? Because there are also some, there is any possibility that the miners do something to...
Have you ever heard about the DAO crisis?
No.
The DAO, the creators of Ethereum, created a platform for a huge smart contract that was a platform to trade services. What happened is that someone found a vulnerability not in Ethereum, but in the implementation of DAO. Because Ethereum is just a platform for smart contracts. Then you have to do the contract, and it has to be correct, has to be the right properties, it has to be the right authentications. It's just a platform. Then you may get the contract wrong. A researcher found that the DAO had a bug, and he could drain money without trading anything. So I think that he got $40,000 worth of things, or $4 million worth of things, without trading anything. And what happened was that since the DAO was so in its infancy, they branched the blockchain, which goes against the ethics of blockchain. So you manipulated the blockchain because you did something wrong. Why should I trust you now? You own the blockchain and you decided to manipulate it because you did something wrong? No, according to the blockchain, that's something that's written forever. You just can go pick the eraser and just remove that. Even in distributed ledgers, you have trust issues. But the thing is that those trust issues are not as obvious as this guy has the data.
Thank you.
Two more questions, so it's your... Yeah.
Also, if, for example, if the mining nodes are competing in the blockchain, I mean, if in this moment we want to become a miner, it's impossible because you need a computing engine that is not possible. So blockchain now is controlled by mining pools. Mm-hmm. So if someone builds a supercomputing mining pool, it's going to win all the competition. So at the end, it's going to become the controller of the ledger.
That in fact happened. One of the mining pools once got 51% of the mining power. And what happened is that there was an agreement. Again, agreement, it's about trust and consensus. There was an agreement, so that pool removed miners. So it went back to the 40% of the mining power. So again, the fact that you store that in a blockchain doesn't remove all the issues. It still has issues. It's just that at least it's distributed. But of course it still has issues. What you said, it has already happened.
Do you think it's an issue for the new private blockchains that is going to appear in the future?
Yeah, I mean, there will be private blockchains. There will be oligopoly blockchains in which some banks or some institutions decide to make a blockchain only for them, for things that are for which they don't even trust each other. And there will be smart contracts with centralized ledgers. I think that there will be a whole family of smart contracts running on different storage strategies. That is my guess. I may be wrong.
Okay, so thank you once again, Guillem. For me, it was really enlightening. Let's give him another applause.